hours lecture, 2 hours duration. So that is the reason why I'm considering the last class lecture as a lecture number 10 and 11, and this will be our lecture number 12. I hope the things are clear. And now I would like to remind what we have done in the last class. In the last class, we started with the error function, and then we tried to plot some Q function, error function, complementary error function, all those things we tried to plot. And we have taken the generalized multivariate Gaussian random variable. And if you are sure, this is the equation what we had considered, where C is the covariance matrix and X is a vector. Now, instead of considering a single sample, we are going to consider multiple samples, and now the random variable X is a vector and mu is also a vector, C is a matrix, and then here X bar, and there is no transpose in this particular region. I hope you can able to see where I am writing over here. So this we have taken, and then we have solved an SMK problem, detection of DC level. And instead of going with the conventional thing, we try to use this matrix notation, and then we try to came to our conclusion that the final expression, likelihood ratio, what we have obtained, this one remains the same as the one which we have considered as the one which we considered without using this vector notation of Gaussian random variable. Vector notation of Gaussian random variable. Okay, now detection of. Now, what I would like to say is detection of known signal. DCTIO, detection of So we would like to see how to detect a known signal, and this topic I am going to deal from chapter 4. Actually, chapter 3 in from SMK. Chapter 3 from SMK is completely included in the textbook. If you look into the contents, if you want me to show me the contents, I can show it to you. Yeah, chapter 3. So Neyman-Pearson receiver operating characteristics is not that much difficult. You can have a look onto this. Irrelevant data. Of course, minimum probability of error is very easy. You just have a look into it. And I covered also 3.6. I also already covered 3.7. Base risk is also covered. Multiple hypothesis. An example was given over there. Just have a look onto that. So total chapter 3 is included in your chapter 3 is included in your curriculum. Now I am going to look into this deterministic signals, particularly how to detect a known signal in the sense, suppose I have a signal S of n. Now earlier detection of known signals in a noise. So this we will try to address today, and I am just following the SMK textbook only for this also. And detection theory by Hippenstall, he also covers this topic, but the thing is he always considers the variables as continuous variables, whereas we would like to have each and everything in a discrete variables. Okay, so for that matter, even the previous discussion what we had, that also was discussed in Hippenstall in a continuous variable. So anyway, let's start our problem. So under hypothesis H0, W of n, which follows Gaussian distribution with the mean 0 and sigma square variance. And under hypothesis H0, S of n plus W of n is transmitted. Okay, so these are the two hypotheses that was given over here. One point what I would like to say is earlier you try to observe this S of n. S of n is a time varying signal. It might be a sinusoidal signal, it might be a USB signal, or it might be any signal. So S of n is a time varying signal. Okay, so how to handle such problem? Under hypothesis? So that means I can able to write let me make it a little bit more clear. Under hypothesis H0, my received data y of n is equals to W of n. Under hypothesis H1, my received data y is equals to S of n. And of course, unlike the single sample case, because here n is there, so n number of samples, n is going to vary from 0, 1, 2, and so on up to n minus 1. Okay, now we will restrict ourselves to only NP detector. We will restrict ourselves to NP detector only for this particular problem. Yeah, can't we go for any other detectors like a min-max detector, map detector, maximum likelihood? Yeah, we can go, but let us try to solve this problem for NP detectors, because NP detector is one of the mostly used, mostly practically used detector, most positive, practically used detector. Okay, so the application of NP, Naiman Pearson detector is predominant. Okay, so I believe the required information is given to you, and of course the probability of false alarm, that let the Lagrangian multiplier or the threshold. So meantime, I'll give you a couple of minutes, maybe 1-2 minutes. I want you to get the expression for L of y. And of course, as per this NP detector, we will be having the equations less than greater than lambda, where lambda is the Lagrangian multiplier. Here we'll be having h0, and here we'll be having h1. So I just want you people to get the expression for L of y. Could you please let me know what is the expression for L of y? Try to take a little bit time. Maybe 1 minute time is insufficient enough. Up to 12:36, I can give it to you. Those people who get the final expression for L of y, please let me know. Share your screenshot. So this lambda is Lagrangian multiplier.
Sir, what is the mean of S of n?
So if I don't give that answer, can't you make it? Shivshankar, if I don't answer your question, that means
Okay.
can you able to get the expression for L of y if I don't give the answer to the question what you have asked? Because it's not that much required. The mean of S of n is not required. See that S of n may be some deterministic signal, or it might be something like a speech. Are you getting what I'm saying?
Yes, sir.
So it's already 37, 12:37. Chiranjeevi,
Sir,
what do you mean by L of y?
probability of y by h1 divided by probability of y by h0, sir.
What is the name of it? L of y. What is the name of L of y? What is the name of L of y, Chiranjeevi? Akila,
Sir,
what is the name of
likelihood ratio.
likelihood ratio, right? Okay, if you try to apply logarithm to likelihood ratio L of y, that means log of L of y, you will be calling that as log likelihood function. So that is required over here, I think, if I'm not wrong. So when you try to apply logarithm for the likelihood ratio L of I, then we will be calling it as log likelihood. The terminology log likelihood, you will be coming across many ways in future. Log likelihood function. Yeah, Chiranjeev, you should understand the terminology also. Straight away doing the things is not sufficient.
Okay, sir.
L of I is the ratio, P of, whatever you told, P of Y given H naught, that is the likelihood function. Probability of Y given H naught, probability of Y given H1, those two are likelihood functions, and if you are going to take the ratio, that is called the likelihood ratio. And if you apply logarithm to the likelihood function, then we will be calling it as a log likelihood function. So I think someone has shared something, so let me have a look on that so that the others may follow it. No one has shared. Yeah, sorry. I'm just waiting for your. Please. Those people who completed, please share the screenshot. Why to waste this much amount of time?
Sir, how to take the mean of S of n without mean, which I did not solve. Sir, how to take the mean of S of n?
S of n గురించి మీకు ఏం తెలుసు ఒక మాట చెప్పండి. What do you know about this S of n? Please let me know.
It is a signal, sir.
So probability of Y given H1 is equals to yeah, this might be the same summation 2 pi. Two pi sigma square whole to the power of n by 2. Chiranjeev or Shivshankar, I hope you are following.
Sir. Yes,
So
sir.
exponential minus 1 by 2 sigma square. ఏమండి మీరు ఎందుకు అంత టెన్షన్ పడుతున్నారు? ఇప్పుడు you are going to receive the sample y of n, right? Y of n means y of 0 is the 0th sample, y of 1 means first sample, y of 2 means second sample. Am I right or wrong, Shivshankar?
Yes, sir.
So if y of 0 is the sample that you have received, then that sample is equals to s of 0 plus w of 0. Am I right?
Yes, sir.
So w of 0 is anyway noise, and s of 0 will be some value, some amplitude value you will be getting. What is the need of having the mean value of s of n? You tell me. It is just a number. S of n is a constant.
Okay.
What okay? See, very simple things if you are unable to apply over here. There you go. Someone has sent this thing to me. So yeah, 2y is not. Yeah, ultimately the final equation will be some expectation of summation minus 1 by 2 sigma square s square minus 2. Yeah, this is right. This is right. So the one who sent this to me, I'll be copying this image as it is, if with your permission. So what the person has written is expectation. How to make this? Yeah. Can I copy this? I believe I can. Copy image. So the one who sent this, the person has done the right thing. So anyway, this you people can able to fill it out. So I just want to paste it over here. Control V. So it is somewhere over here. Atland. So you are going to have the likelihood ratio L of y is equals to probability of y given h1 divided by come on. Why this is so much slow? I'm not getting here. Yeah, probability of y given h naught So the person who sent this thing, can I know the name of the person? Yeah, mute
Akila sir.
Akila, okay, very good. Is equals to Akila, you just try to apply natural logarithm on both sides. Apply big. You see the question what was asked by Shiv Shankar, that may be the valid question or that may not be the valid question. The reason why I am saying this thing is y of n is equals to s of n plus w of n. You try to see s of n. When I try to take n is equals to 0, when I try to take n is equals to 0, y of n is equals to s of boy. When n is equals to 0, s of 0 plus w of 0, we decided that, or we earlier in our discussion we considered w of 0 as a random variable. W of 0 is one random variable, w of 1 is one random variable, w of 2 is another random variable, right? So that means s of n or s of 0 plus w of 0, w of 0 is the random variable and s of 0 is the sample of the signal s of n at n is equals to 0th location. That means you may get the value as some constant. So if it is sinusoidal signal at s is equals to 0, whatever the amplitude you are going to have, that we will be having. So that means indirectly we are going to add some constant to a random variable. That is the meaning of the expression s of n plus w of n. So w of n is a random variable and s of n is a constant, and you are going to add a constant to a random variable w of n, where n is equals to 0 means one random variable, n is equals to 1 means another random variable. Are you getting what I am saying? So the moment when you try to perform the expectation of this, it will be the mean value of the w of 1 plus, of course, you know, when a random variable is added with some constant, what will be its mean value, right? So as Akila written over here, I would like to copy the same expression over here, or else Akila can share me the final expression after applying natural logarithm on both sides. And you people also can do the same thing. So this will be exponential. Oh my God. Shall I take a new lecture notes? Exponential of I'll take common minus 1 by 2 sigma square. Minus 1 by 2 sigma square. If I try to take common, so here I'll be getting si square. Yes. of I square minus 2 multiplied with s of I, y of I, and of course I should keep here one summation. So I would like to keep here one summation.
Sir, I see the answer.
Now this is not required. So, and of course there is some bracket over here, and here I is going to vary from 0 to n minus 1, and this is equal less than lambda, which is called the Lagrange's multiplier. Here we are going to have h naught, here we are going to have h1. And if you try to apply natural logarithm on both sides, and let us try to follow what was being sent to us. Oh, no one has sent. Akhila, did you send another one? Yeah, I think. So this is what the final expression is, if I'm not wrong. Summation sigma square yi si sigma square natural logarithm of lambda plus I'll try to write it in this way. So what she has written is the same, but I'll try to make it. So others మీకు the same వస్తుందండి. So if others follow this, I don't have any problem. So the final expression will be the test statistics T of y. T of y is equals to, I believe, what do you mean by test statistic? You might have known this because in the last class we have discussed about this test statistic. So summation n is equals to 0 to summation n is equals to 0 to n minus 1. N minus 1. You are going to have y of n multiplied with s of n. And of course, there will be a threshold less than or greater than h naught h1 sigma square into natural logarithm of lambda, because we consider it as lambda, plus lambda 1 by 2 times summation n is equals to 0 to n minus 1 s square of n. So this will be your final s square of n. Akhila, I believe the expression what you have shared and this expression both remains the same, right?
Yes, sir.
So I hope others also have obtained the same equation. So we always use it to consider the right side part as another threshold gamma. Let me assume this as some gamma. So let me assume the right side part as some gamma. So you'll be having less than, greater than gamma, and of course T of y. Okay. So what is our aim over here? We would like to detect the deterministic signal. When I say deterministic signal, I can able to assess what s of n will be at any point of time. When n is equals to 10, what is its value, s of n value? When n is equals to 20, what is its value? I am in a position to assess this, right? So this is an NP detector, and as expected consists of a test statistics T of y. And of course, the similar problem we have done in the last class, where the test statistic is the mean of the samples that we are going to take, right? So the left side part will be 1 upon n summation n is equals 0 to n minus 1 y of n in our last example, previous example in the sense of the example of what we have discussed in the last class. So the left side part is nothing but the mean value of the total samples what we have taken. But now here, instead of having this there, if at all I'm not wrong, we are going to detect the DC value, but here we are going to detect a signal, whether the signal S of n exists or not, right? So of course I'll be following this condition, and if it is the gamma value, you can able to get from the probability of false alarm that will be given to you, provided to you in the problem. So people will be giving you the probability of false alarm. What is the probability of false alarm that a receiver can able to handle in that particular application? If that value is given, then from that you can able to get the lambda value. And of course the signal S of n is anyway deterministic signal, and you have the information about the signal S of n. S of n is not a non-deterministic signal, it is a deterministic signal, and you have the signal that at hand. That means at the transmitting end, you let us assume that it is a simple sinusoidal signal. So at the transmitting end, when I'm going to transmit bit 1, I'll be sending a sinusoidal signal with let me consider 3 cycles. Okay, so sinusoidal signal I'll be sending 3 cycles during the portion when I'm transmitting bit 1, and during the transmission of bit 0 I'll be sending nothing. So that means I'll be receiving only W of n. So that's the equation that was given at the beginning of the problem. So your Y of n is equals to W of n under hypothesis H0, but that means 0 is being transmitted. Under hypothesis H1, Y of n is equals to W of n plus S of n. A signal is being transmitted. Okay. In our last class example, instead of the signal S of n, we consider it as a DC value capital A. So if you try to substitute the DC value capital A in place of S of n, the equation what you have obtained over here, the test statistic will remain the same as that of the one which we have derived in the last lecture. If you want, you can verify it. Chiranjeev, is it the same equation or different equation?
Same equation.
Same equation. I hope Yashwant also do agree with this point. Am I right, Yashwant?
Yes, sir. Same equation.
So when you replace S of n with a constant capital A, whatever the test statistic that you are going to have will be the mean value. If you try to rearrange the terms that was there in the equation that was being displayed to you, right? Now, instead of taking S of n as a constant capital A, let us try to consider S of n as some R to the power of n. R to the power of n. So R to the power of n means the signal that is being transmitted will be R to the power of n, means R power n is equals to 0, means R power 0 is 1, R power 1, R value, let me take R value as some 2 or 3, let me take it is 2. So that means I'll be transmitting, R power n is exponentially increasing function, right? So when R is equals to 0, the value will be 1, and R is equals to 1, the value will be 2, R is equals to 2, the value will be 2 square, that is 4, R is equals to 3, the value will be 2 cube, that is 8. So that means it will be exponentially increasing values, R to the power of n values. So if it is the case, the test statistic will be, it's not the average as though we are going to have in the case of a DC value. It will be the weighted average of the samples that you are going to receive. So that means how much weight you are supposed to take, that is going to be decided with the sample number and the signal that you are going to have. For suppose if the signal S of 3 is going to have the value R to the power of 3, if R is 2 to the power of 3, that means the weight that you are going to give the for the sample W of 3 or for the sample Y of 3 is 8. So Y of 0 is one sample, Y of 1 is one sample, Y of 2 is one sample, Y of 3 is one sample. So Y of 0 is given the weight of R of 0, R power 0, R power 0 is 1. So Y of 0 is given a weight of 1. Y of 1 is going to given a weight of 2 because the R value we have taken as 2. Y of 3, Y of 2 will be R2 square, that means 4. That means Y of 2 is given the weight of 4. It is nothing but the weighted average. Are you getting any sense of this problem? Susan?
Yes, sir.
So, this is what the way how we are going to do the detection of deterministic signal. So if it is a single sample, it is very difficult to identify. See, with a single sample, you cannot judge whether the transmitted single signal is a sinusoidal signal or exponential signal or DC signal. It is very difficult. So you are supposed to take multiple samples, no doubt in that. Okay. And if you try to observe the term that was given over here, this term, what is this term? Whom should I ask? Naresh, what is this term? The one that was encircled? Naresh? అదేంటండి సెకండ్ టర్మ్ ఏంటది?
మీన్ స్క్వేర్ వాల్యూ డివైడెడ్ బై 2 సార్.
ఆ 1/2 కాసేపు పక్కన పెట్టండి. సమ్మేషన్ n is equal 0 to n minus 1 x square of n. What do you mean? How do you call that?
మీన్ స్క్వేర్ వాల్యూ.
ఇక్కడ ఎర్రర్ ఎక్కడి నుంచి వచ్చిందండి? From where you have obtained this error? Dhanashri? Dhanashri? Are you there? Ravina? Ravina? Ravina is not there. Dhanashri is not there. And why very less number of people were present today? Yashwant, Bhavan, Suresh. Suresh!
Yes, sir.
So what is that second term? Okay, Suresh, let me ask the question something like this. If you are provided with a signal S of x of n, Suresh,
Yes, sir. Yes.
a signal x of n is given to you and you are asked to find out the energy of the signal x of n. How you will be calculating it? Suresh, సురేష్ కనీసం ఈ క్లాస్ టైంలో అన్నా మీరు కొంచెం మిమ్మల్ని మీరు ప్రైవేట్ గా ఉంచుకోవాలండి. unnecessary disturbance we are getting. Of course, that might be the necessary for you, but Suresh.
Yes, sir. Yes, sir.
Sir. Yeah, Dhanashri.
Yes, sir.
So what is the second term? What we call the second term?
Sir, is it power of the signal?
So I believe you know the difference between the power of the signal and energy of the signal.
Yes, sir. Energy is summation modulus of the square.
And power?
Modulus square of the signal. Power is 1 by 2 times the time duration and summation modulus square of the signal.
So is there any time duration in the denominator?
No, sir.
Then how you will say that it is a power? It's a simple energy of a signal.
Yes, sir.
This is a simple energy of a signal. Of course, you can keep this 1 by 2 outside. This is energy of a signal. Any doubts up to now? మాట్లాడరు ఏంటండి? Okay, Dhanashri, could you please let me know what you are going to observe from this particular equation? Okay, anyway, this whole term, I'll encircle this with this whole term. I'm going to replace with a simple value gamma. Okay. So I want Dhanashree to comment on the term that you are going to have in the left side. That means the test statistic. Dhanashree, could you please comment on
Yes,
the test statistics T of I?
sir, it is the summation of energy of the signal and sigma square into ln of lambda.
I'm asking you to comment on this T of Y, test statistic. Okay, does that equation is similar to correlation equation or convolution equation? Can you please compare this equation with the correlation or convolution?
Correlations.
So, someone told me that it is a correlation. So, if I try to implement this using a hardware, so how I'll do the thing? So, I'll try to receive a signal y of n. I'll try to receive a signal y of n. Of course, that signal I'll try to multiply with x of n. I'll try to multiply with x of n. I'll do one thing, yeah. So at the receiver end, can we have S of n? Of course, I'm designing a receiver. This is a receiver. So from that noisy channel, I'll be getting some data y of n. I'll be getting from noisy channel. So the moment when I try to get a sample value, of course, before this, I'll try to do a sampling also. And when y of n has been received, that will be multiplied with the corresponding S of n. I know what is the signal that has been transmitted at the transmitting end, so I'll be multiplying it. And after performing the multiplication, what I'll try to do, I'll try to send it to a block which will perform the summation of all the products that was being received. That means y of n multiplied with S of n, whatever the values that you are going to have. Here you will be getting y of n multiplied with S of n. And here you will be having summation y of n multiplied with S of n. Of course, the n value what you would like to have 0 to n minus 1. So if you are going to have n samples, and this is being sent to, and of course this I will be considering test T of y, the test statistic T of y. And anyway, I'll calculate this gamma value from probability of false alarm, and I'll keep that gamma value over here, gamma. So I'll be taking the decision ink to shape, ink to table, format to clear camera, check and feedback. Okay. I really don't understand why the screen goes very slow. So if this is less than gamma, I'll take the decision towards H naught, and if this is greater than gamma, I'll take decision towards H naught. And equal to sign, whichever the place that you would like to assign, that you can able to assign. And I'll call this as correlation receiver. Is it the correlation receiver or not? You are just going to calculate the correlation between the received signal and the signal that you are going to be transmitted. Am I right or wrong? Correlation receiver. Student, is it clear? Students, is this clear?
Yes, sir.
Okay, thank you. So now we designed a receiver. This is actually the receiver. And we named this as a correlation receiver because this is the portion where we are going to calculate the correlation between the received signal and the transmitted signal. The transmitted signal is S of n actually under the hypothesis H0. So the moment when you calculate the test statistic T of y, and if the T of y is less than the gamma value, the threshold that we are going to get from some constant, then we'll take the decision towards H0, otherwise we'll take the decision towards H1, right? Now, so up to this, we have seen the correlation receiver. Now I'll try to do one thing. Try to be very careful now. So I have a black box, and its impulse response is h of n, and I am feeding this with s of n. Let us assume that the input is the signal s of n or x of n for that matter. If x of n is the input signal, okay, fine. Let this be my x of n. And we are going to have y of n. And let us assume that h of n is FIR filter, finite impulse response filter. So it's not that much worried. It's not required to worry about this FIR filter as of now. So if anything is required, I'll try to explain it to you later. So we know that y of n will be the convolution summation of x of n, x of n, and h of n. X of n convolved with h of n. Here this indicates the convolution. So this is a standard terminology in the sense if at all you would like to find out the response of a system, you will be doing the convolution between the input and output, between the input and the system impulse response. And that's what is being given over here. So now what I'll try to do, I'll try to write the expression now. So y of n is equals to, okay, I believe you people know what is the expression for a convolution summation. So I want you people to try it from your side. So x of n Okay. Yeah, let me start with h of n minus k x of k. And here n is going to vary from, sorry, k is going to vary from 0 to 0 to, yeah, students, I believe you people are okay with my equation of convolution that was written over here. Am I right or wrong? Summation k is equals to 0 to n. I'll write here. Or I can write this as capital N minus 1 also. See, if you have any doubts, you can ask me. Whether you people agree with me or not with this particular equation, which is the relationship between the input and output of a discrete system h of n. And this equation is actually the convolution summation. Do you agree with this equation? Yes?
Yes, sir.
I need 2, 3 s here. I would like to, yeah, one more s. Suresh, is this okay? The
Yes, sir.
response of a filter y of n is given by the convolution summation between, you see, either convolution between x of n and h of n is same as the convolution between h of n and x of n. So it won't be that much difficult if you try to have this argument over here. Okay. Now I want you to compare this equation with the equation of the test statistic. I would like you to compare this equation with the test statistic. That means I would like to know the value, what is h of n. I want to know the impulse response h of n, so that I'll be, instead of using this correlation receiver that we have obtained over here, I would like to have the value of h of n so that a straight away FIR filter can be used. Straight away FIR filter can be used. Are you getting what I'm saying? So you try to compare this with your test statistic. Actually, the test statistic L of y, of course, after performing the natural logarithm, can you compare the test statistic with the convolution equation and then get me the expression for h of n so that I can use the filter h of n to perform as a receiver? So if I try to consider h of n as substitute this h of n in your convolution equation and try to look into this y of n equation. So when I try to substitute this h of n over there, you will be getting y of n as y of n is equals to summation k is equals to 0 to n minus 1 h of n minus k. So s of n minus 1 minus n and then you will be writing here minus k. In place of n, we are supposed to write n minus k. So I will be writing n minus k. Because see here, the n has to be replaced with n minus k. So s of n minus 1 minus n minus k, x of k, which is equals to summation k is equals to 0 to n minus 1 s of n minus 1 minus n plus k x of k, and this is y of n. Remember one thing, the maximum value of here n minus 1 can be replaced with small n in your convolution equation. This can be replaced with small n. This can be replaced with a small n.
Sir, your voice is not coming.
ఎంతసేపు అయిందండి ఇది పోయి?
10 minutes అయింది సార్.
మరి 10 minutes నుంచి ఏం చేస్తున్నారండి? నేను ఇక్కడ వాక్కుంటా కూర్చుంటే. కాదు 10 minutes నుంచి మీరు కనీసం మెసేజ్ అన్నా పెట్టాలి కదా! నేను ఇంకా ఇది పోతుంది అంటే మీరు ఫాలో అవుతున్నారని చెప్పేసి నేను చెప్పుకుంటూ పోయాను 10 minutes వరకి. మీరు ఏదో ఒకటి చెప్పాలి కదా సార్ మాకు వినిపించట్లేదని మెసేజ్ వాట్సాప్ మెసేజ్ నాకో లేకపోతే రీసెర్చ్ కాల్స్‌కో గ్రూప్‌లో ఏదో ఒకటి మెసేజ్ పెట్టాలి కదండీ! మిగతా వాళ్ళు ఏమైపోయారు? శివశంకర్. దేవుడా! మిగతా వాళ్ళు ఏమైపోయారండి?
All are present, sir.
Where all are present, sir? Only 1, 2, 3, 4, 5, 6 people only present. I think Dhanashree is not here. Suresh is not here.
Sir, I'm present.
Sorry. Suresh is not there. Huh? Ravina is not there. So till what point you have understood, you just let me know. After that I'll try to conclude it in another 2 minutes. See Ravina, Dhanashree, please let me know till what point you understood. From there I'll try to continue it in another 1 to 2 minutes and then I will conclude the session.
Sir, we have substituted h of n equal to s of n minus 1 minus n, and we have just simplified the equation till that point only.
Okay, listen here. So I believe this is the equation for the convolution, right? This is the equation
Yes,
for the
sir.
convolution. Okay. Now one point what I would like to say is if h of n is 0 for the negative argument values. Negative argument values means if n goes to -1, -2, -3, -4 and so on, and if in such cases h of n is 0, then I can replace here I can replace this n minus 1 with n, because I have given an example over here. You try to see. Okay, I want you people to look into this example. See here, two equations were given here, all right? These two represents the convolution. The first one, here the maximum value goes up to n minus 1. Here the maximum value goes to only n. So what actually is the difference between these two? Were these two represents the same or not? That's I'm going to explain it to you now. So if you try to look over here, h of n minus k, if I try to calculate and if I define h of n, my board is not working. Okay, if h of, did I wrote this? Yeah, here. You see. Yeah, we'll continue in the next class then. Dhanashree. We'll continue in the next class. Thank you. Thank you so
Okay,
much.
sir.
Yeah, could you please update me the attendance, Dhanashree?
Yes, sir.
Yeah, all the people can leave the room now. Stop.